Hey, this is Derek, and this is section 9.5, properties of logarithmic functions. And so we have basically three properties. These are, you probably have seen these before. They're the same as the properties of exponents, but just disguised with logarithms. So the first one goes, if we have two things multiplying in the argument of a logarithm, we can rewrite those as addition or vice versa. And the property that this is if we have a to the x times a to the y, that becomes a to the x plus y. And so that's what we're showing. If we're multiplying, we end up adding exponents. Remember, logs are exponents. And so that's what's happening right here. The second one, this is if we have division, we subtract. And that's this one. And so the same thing, if we're dividing with exponents, we keep the base the same, subtract the exponents. That's exactly what we're doing here. And then this third one, this says if we're raising something to a power, we can bring that down front and multiply. And that one is this one, a to the x to the y. When I raise something to a power, then we multiply the exponents. And that's what that's doing. These two are just reminders that if you have a log of the same base and the argument, the base and the argument are the same, that's a 1. So for instance, if I have log base 5 of 5, that says what power do I raise 5 to get 5, so that would equal 1. Likewise, a common one that we'll run into is natural log of e. That one is 1 because remember ln is base e. Log of 1, that one's always 0. And then one other thing that will show up in this section that people sometimes have forgotten is if you have a square root, you can write that as x to the 1/2. And what that's going to let us do is apply this property. So when we have the root notation, we're not seeing the exponents, and that's kind of letting us not use property 3. Likewise, if I have a cube root, then I would just make that a 1/3. And then this is just when you're raising something to a root to a power, you end up power over root in the exponent. And I'll show you that as we do the exponents throughout the section. Okay, so then in this section, we're going to basically see two things. We're going to see expand the log, where we're given a single log and we're asked to write it like this side of the formula, or we will be given something like this side of the formula and asked to write it as a single log. And depending on what we're trying to do with it, sometimes one form is better and sometimes the other form is better. And so just having the ability to write both directions is useful. So for this first example, we're given a log of 7v. So if I'm going to expand that, I'm just going to write log 7 plus log v. And that would be it. This next one, log 10 over d. So that would be log 10 minus log d. This is plus because it's multiply. This is minus because it's divide. Log 7, this is not, that is the exact value that, what do I raise 10 to get 7 is nice. But this one is what do I raise 10 to get 10. So this actually simplifies down to a 1. And then log d. Ln e to the square root of 5. So square root of 5, that's an exponent. So using property 3, I can bring that down front. So square root 5 ln e, and then ln e, that equals 1, and so this is just root 5. This one is that root power thing that I was talking about. So this is log, and this is x to the 10th, and then that's the cube root, so I'm going to write that as a 1/3, and then that's going to let me write that as a fractional exponent. So I'll go 1/3 times 10, and I have log x to the 10/3. And now I can apply property 3 and bring that down front. So 10/3 log x. And that is as expanded as that gets. Okay, for this one, let's think of that fourth root as log x to the 1/4 and y to the 6th. And anytime you see a root, just think fractional exponent. And now here, if you notice so the exponents always become the coefficient of the log, and then because this is division, it's going to be a subtraction. So what this will look like is 1/4 log x and then minus 6 log y. And you can do these with more steps, but you really don't need to. So again, these powers, these are going to be my coefficients. If it came from the numerator, it's going to have a positive. If it came from the denominator, it's going to have a negative. And the reason for that is because I can rewrite this as x to the 1/4 and then y to the -6. And then if I rewrite that as addition, the negative comes down and flips it to a negative, or subtraction in the problem. So any of these things where there's a denominator, that's always going to have a minus in front. And anything from the numerator, always be a positive. So that kind of speeds it up. And that is as far as we can go on that. For this one, this would be log 1 minus, and then that power is 8, so I'll write it as 8 log y. And then log 1 is really 0, because what power do I raise something to get 1 would be 0. So that piece drops out, and 8 log y. Here, so I'm going to have a couple, I'll have 3 logs initially, and then this is going to simplify. But initially I'll have 3 logs, one with x, one with y, one with 1,000. And the x will have a coefficient of 2, because it's squared. And then the y will be positive because it's from the numerator, and I'll have a coefficient of 7. And then log 1,000 will be minus because the 1,000's in the denominator. And then that 1,000, this is really what power do I raise 10 to get 1,000, so that's actually a 3. So 2 log x plus 7 log y, and minus 3. And then number 8, let's rewrite this with a fractional exponent. So log base 5, a to the 9th. And then this is going to be b to the 7/3, because again, that would be 1/3 times 7 for 7/3. And then once we get that, then we got 9 log base 5 of a, and then plus 7/3 log base 5 of b. Okay, so next we have used properties of logarithms to rewrite the given expression as a logarithm of a single quantity, simplified as much as possible. Okay, so for here, basically just try to take it backwards. So this, anytime you see the right as a single log or right as a single quantity, let's start off by writing log just once. A lot of times people will write log, 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 log all over the problem, especially if it's division, you get log over log. It shouldn't be, it should just be a single log. So I'll start there. And then this is going to be x to the 5th, because I have 5, it's positive, it's in the numerator. That's positive, so y squared, also in the numerator. And then for the computer, I'll just point out that the log base 3 is in front of the box. So for these ones, what you're typing is just the argument of the log. This one, so again, I'll write down my single log. This one's base 10, so I don't need anything there. I have a positive 4, so that x is up in the numerator with x to the 4th. Negative 6, so the y is in the denominator. Okay, so this one will go, again, log. And we have both signs, so we're going to do a division bar there. 1/2 log x. I could write that x to the 1/2 or square root x. The computer will take either one. I'll show it as a root. That is a minus, so that means that y to the 4th should be in the denominator. But then it bounces back to a plus, so that just means that the z to the 4th is in the numerator. The order doesn't matter a bit. It's a sign that counts. So, because I could have written this plus and then minus with the y on the end, and I have the exact same thing. Here we'd end up with natural log of 7b cubed over 4b to the 6th. Oh, no, apologies, that's a plus. So natural log of 7b cubed times 4b to the 6th. And then if I can simplify, I will need to do that. So we get natural log 7 times 4 would be 28. B cubed times b to the 6th for b to the 9th. 13. So this one's a minus. This will be a division. Log 12x to the 6th, and then over 4x squared. Again, because that simplifies, I want to keep going. So 12 over 4 would be 3. And then x to the 6th over x squared would leave me x to the 4th. And then remember, our goal here is to write as a single log, so we don't want to go expanding that again. That's as far as we want to take it. And this one, let's see, so log x squared. And then this is just the binomials all, and then raised to the 5th would be it. And so then the square root, I think I will simplify that first. So let's go log, square root 16 would be 4, and square root of x to the 10th would be x to the 5th, because x to the 5th times x to the 5th makes x to the 10th. And then this is, let me just leave that there for a second. And then I'll bring this into a single log now. So we have log of the numerator's 4x to the 5th, and the denominator is going to be that x cubed. And then I can reduce a little bit right there. And 4x squared. And then this last one, so this is a minus, so we'd have log of x squared minus 81 over minus 2, so that's going to be x minus 9 and squared. And then that's a difference of squares, so that's going to factor a little bit, so I am able to reduce. So x plus 9 and x minus 9. And then that squared means I have 2 factors of x minus 9, and I can reduce those out.